Hey guys, it's Miss Miklos, and today we're talking about absolute value inequalities, and a lot of that is going to build on what we learned last time with our inequalities, but we do need to pay attention to this idea, I didn't mean to move that, of absolute value here. So we need to remember that absolute value means that it is the distance something is from zero on the number line. And that's why whenever you guys see absolute value, you normally think that it's always positive because we know distance can never be a negative value. So the fact that it's a distance means that it's going to be a positive value. If you're running around the track, it doesn't matter which way you're running, that's always a positive distance. So same idea here, whether we're to the right of zero or to the left of zero, it's always going to be positive. So the question is, how do we solve absolute value inequalities? And we're going to be using the same steps every single time. And I'm just using AV because I'm being lazy and I don't want to write out absolute value, but that's what it means. So the very first thing we're always going to do is isolate the absolute value. And a lot of the time, this is actually going to already be done for us. Then we're going to go ahead and set the expression equal to the number and to its opposite. And the reason why we're going to do this is because if I had like the absolute value of 5 and the absolute value of negative 5, notice both of those outputs become positive 5. So if I end up having something like x minus 2 equals 5, okay, I need to go ahead and set x minus 2 equal to 5 and equal to negative 5. Okay, so that's the thought process on why we're setting the expression equal to the number and its opposite, and that makes more sense when we do some actual problems. Then we're going to go ahead and solve for the endpoints. So we're actually going to solve those equations. And our final step, we're going to check the different intervals for shading. So here's number 1. And the first thing we said we want to do, we want to make sure our absolute value is isolated, and in this case it already is. So I'm going to go ahead and I'm going to take whatever is inside the absolute value, so everything right there, and I'm going to go ahead and set that equal to 5. And also set it equal to negative 5 because I'm setting it equal to the number and to its opposite. So now I'm going to go ahead and solve for my endpoints. So I would subtract 3 from both sides and divide by 2. I would subtract 3 from both sides and divide by 2. So if I'm making my number line here, here is negative 4 and here is 1. So we solved for the endpoints. If we ever have an equation, which on the homework you guys actually do, this would be our final answer. But we know with inequalities, we're trying to find where are those values less than 5, so we need to think about this number line. So I'm going to start to the left of negative 4, and I'm going to choose negative 5. And what I'm doing here, I'm going to go ahead and substitute that in for x, and I want to see if this creates a true statement or not. Okay, so I have the absolute value of 2 times negative 5 plus 3. Is that less than or equal to 5? So I get negative 10 plus 3, which is negative 7. Is 7 less than or equal to 5? No, it's not. So what that tells me is that this section over here does not contain any solutions. Now I'm going to choose a point in between. 0 is by far my favorite point because it's the easiest to substitute in. So I'm going to go ahead and substitute that in. And I get the absolute value of 3 is less than or equal to 5. Is 3 less than or equal to 5? And our answer is yes. So that tells me everything between negative 4 and 1 are going to be solutions. And lastly, let's try something to the right of 1, like 2. Now, as I'm writing this out, just so you guys know, I'm thinking it probably isn't going to work because most of the time I'm either shading on the outside or in the middle. That's not going to happen every time, and we'll see that in action today. But when I go through this, I get 7 is less than or equal to 5, and that's a no. So that means the only region that I'm shading is inside. I also need to think if I should use parentheses or brackets. This is going back to interval notation that we learned last time. And since this says less than or equal to, I know that I'm going to have to use brackets. So I'm going to go ahead and shade in between and use those brackets. My answer in interval notation would be -4 to 1. And I'm using brackets once again because it's including those values. Okay, number 2, another pretty straightforward one. My absolute value is already isolated, so I'm going to go ahead and set x minus 16 equal to 24. And I'm also going to set it equal to -24. And once again, the reason why I'm doing this, if I put 24 into the absolute value, 24 is 24 places away from from 0. So it makes sense that if this is equal to 24, these two sides would be equivalent. Likewise, -24 is also 24 spots away from 0. So if this is equal to -24, these two sides will be equal. So if I'm working this, I get x equals 40. And I don't know what I'm trying to continue to solve there. That's my answer. And then when I add 16, I get x equals -8. Okay, so here's my number line. I do need to make sure -8 is on the left, 40 is on the right. So this time, I'm going to try something like -10. And I get the absolute value of -26 is greater than 24. Is 26 greater than 24? Yes. And the work that I'm writing out here, this is stuff that you guys really can do in your head. I'm just showing it to us so we can see that. Okay, in between, I'm going to choose 0, so I get the absolute value of -16 is greater than 24. Is 16 greater than 24? No. And right away, as soon as this worked, my guess would be that I would also shade over here. But let's just double check. Let's try 46. You might be thinking, why am I doing 46? Well, because 46 minus 16 is 30. That was just easy for me. So I get 30 is greater than 24, and yes, that works. So this time I need to determine, should I use parentheses or brackets? Since I do not have equals to, I'm going to use parentheses, and I'm going to shade to the left, and a parenthesis, and shade to the right. So if we were writing this in interval notation, our answer would be -∞, comma, -8, union, because I'm connecting these two pieces, 40 to infinity. So now that we've got the hang of it, let's try one that's kind of strange. Okay, and I'm letting you guys know this one's strange because of the fact that this is -13. But I'm going to pretend like I didn't even notice that, and I'm just going through my flow here, setting it equal to the number and to its opposite. And if I'm solving this, I get 2x equals -16, so x is -8. I get 2x equals 10, so x is 5. So here's my number line, and I have -8 and I have 5. So once again, let's choose a point. Let's do -10. I would get the absolute value of -20 plus 3, which would be -17. 17 is greater than or equal to -13. So right away, if I'm shading here, I'm thinking I'm also going to shade here, but that nothing in here works. And I just want to stress again, because this is a concept that we keep repeating, I always shade where there are solutions. Okay, so if I'm looking in between here, let's try 0, and I would get the absolute value of 3 is greater than or equal to -13. Is 3 greater than or equal to -13? And that's a yes. So this one's kind of weird because it looks like solutions are here and here. Okay, lastly, let's try 6. Okay, I get 12 plus 3 is the absolute value of 15. is 15 greater than or equal to negative 13? And my answer is also yes. So if I was shading what our solutions tell us, I'm shading everything on the number line. We would write this in interval notation as negative infinity to infinity. And if we look back to the original problem, how did I know that this was going to happen? Well, I know negative 13 was kind of weird. I know an absolute value, its output has to be positive. So this is telling me a positive number is greater than negative 13. Well, that's always going to be true. So even without doing all my work, I could have deduced that this was going to be our final answer. Number 4 looks really similar, except this time I have a negative 2 over here. So I'm going to think for a moment, okay, this is a positive number. Can a positive number be less than or equal to a negative number? And our answer here is no. So our answer would be no solution. And if you did this the long way and set it equal to negative 2 and positive 2 and graphed it on the number line, the issue you would see is that none of those intervals would have values that work. So you would not shade anywhere. Okay, so back to like the more normal ones, or are they? Yep, we have a negative 2 over there, but I want to point out that my absolute value is not isolated. Okay, so if this idea confuses you, I just want you to think, how would we isolate x in an equation like negative 4 plus 2x is greater than negative 2? Because this equation, or I'm sorry, this inequality is really saying the same thing. It's just that we have an absolute value there instead of the x. So some things that I'm going to do, I'm going to add 4 to both sides. So I get 2 times the absolute value of 3x minus 5 over 2 is greater than 2. And then I'm going to divide both sides by 2. So I get the absolute value of 3x minus 5 over 2 is greater than 1. So I'm going to say 3x minus 5 over 2 equals 1. 3x minus 5 over 2 equals negative 1. So I'm going to multiply both sides by 2. And I get 3x minus 5 equals 2. When I add 5 over, I get 7, and divide, I get 7/3. Over here, I'm going to do the same thing and multiply by 2, so I get 3x minus 5 equals negative 2. When I add 5 over, I get 3, so x is equal to 1. So on my number line here, here's 1, here is 7/3. Let's see what works. So over here, I'm going to pick my favorite number, 0. And I'm not even going to write out all my work here. I'm just going to kind of talk us through it. We can definitely use this long, complicated inequality, but I think life would be much easier if we substitute into here. So if I put 0 in for x, I would get the absolute value of negative 5 halves, which is 5 halves. 5 halves is greater than 1, so it does work over here. In between would be something like 2. If I put 2 in, I would get 6 minus 5, which is 1/2, because I would get 1 and then that over 2. 1/2 is greater than 1, and that would be a no. To the right, let's try something like 3. If I put 3 in, I get 9 minus 5, which is 4. 4 over 2 is 2. 2 is greater than 1, so I'm going to say yes. Since I have a greater than and I don't have that equal to, I'm going to go ahead and use parentheses. And I'm going to shade on the outside. So interval notation, I would say negative infinity to 1, union, 7/3 to infinity. Okay, one final problem here. And I put this one on just because sometimes I think fractions freak us out. So I have 1/2 x plus 3 halves equals 1/8. And 1/2 x plus 3 halves equals negative 1/8. There's a few different ways we could go about this, but I don't like those fractions. So I'm going to multiply everything by the LCD, which in this case is 8. So when I distribute, I get 4x plus 6 equals 1. So I'm going to subtract 6 from both sides, and I get x equals negative 5/4. Notice I'm keeping that as an improper fraction. I'm going to go ahead and do this second problem in a similar way and multiply by 8/1. And I would get 4x plus 6 equals negative 1. So when I subtract 6 this time, I get negative 7. So x equals negative 7/4. So I need to think, what is smaller, negative 5/4 or negative 7/4? And negative 7/4 is smaller. So I'm going to go ahead and put that on the left. A value that would be to the left of negative 7/4 would be something like negative 2. Okay, if I put that in, I would get, now I'll write this out, I would get the absolute value of negative 1 plus 3/4 is greater than 1/8. So that's telling me 1/4 is greater than 1/8, which is true. Okay, so I'm thinking we're shading to the left. I would also think that we're probably shading to the right, and I'm going to put in 0. So if I put 0 in, I end up getting 3/4 is greater than 1/8, which is also true, so I'm going to shade. If I had tried something in between, I might do like negative 6/4 or negative 3/2. Okay, and if I did that, I would get negative 3/4 plus 3/4, which is 0, is greater than 1/8, and that would be a no, so we would not shade in between. So on your homework tonight, whenever we have an inequality, we need to make sure that we are graphing our number lines. Okay, the last step here, and this is kind of like the added bonus, is writing it in interval notation. So I'm just following along and writing that out. So it'd be negative infinity to negative 7/4, union negative 5/4 to infinity.